Hello and welcome. Today we are diving deep into a bug that I'm sure gives many of you headaches at the bench. It's a real challenge in the hospital setting, the intrinsically multi-drug resistant Stenotrophomonas Maltophilia. So let's start with a classic benchside scenario. You've got a non-fermenter growing. First test, oxidase-negative. So you're already thinking it's probably not Pseudomonas. You look at the antibiogram, and yep, it's resistant to every single carbapenem you've tested. For the final confirmation, you run a DNase test, and it's positive. So what bug is screaming out at you?
You got it. It's Stenotrophomonas Maltophilia. This organism is just a classic opportunist, and it has a real talent for popping up in our most vulnerable patients, which makes getting that ID right and getting it fast absolutely critical.
Now, just so you know, all the information we're about to go through has been pulled together from a pretty comprehensive Gemini deep search. If you want to dig into the primary literature and all the guidelines yourself, you can find everything in the full notebook document. All right, so let's start right where the action begins for us, in the lab. How do we nail down the identification of this tricky pathogen and make sure we're not confusing it with any of its other non-fermenting relatives? This table is really your go-to cheat sheet. That negative oxidase reaction is, of course, the big first clue that separates it from Pseudomonas aeruginosa. But the real 1-2 punch that clinches the ID is the combination of being positive for both DNase and a lysine decarboxylase. That unique profile really sets it apart from both Pseudomonas aeruginosa and the Acinetobacter baumannii complex. And on the plates, all the little clues start to add up. You got a small gram-negative rod. On your McConkey agar, it's a non-lactose fermenter, as you'd expect. But if you give it a little time, the colonies often develop this really characteristic lavender green color. And we absolutely cannot forget about its incredible ability to form biofilms. I mean, that's a huge piece of the puzzle for why it's so good at causing device-related infections. But, we're moving beyond just the traditional culture methods. For really fast and definitive ID, molecular is the way to go. And while 16S sequencing is common, targeting the 23S rRNA gene actually gives you better specificity. Even better, there are assays that target a unique 4 kilobase genomic region that are basically 100% specific. And for epidemiology, when you're trying to figure out if you've got an outbreak on your hands, multi-locus sequence typing, or MLST, is still the gold standard. Okay, so we've covered how to identify it in the lab. Now let's switch gears and talk about the biggest clinical question that comes up with this bug. Once you've found Stenotrophomonas Maltophilia, what does that actually mean for the patient? And this really is the million-dollar question, isn't it? Just because you find it in a sputum sample or a wound swab, that doesn't automatically mean it's causing an infection. A lot of the time, it's just hanging out as a colonizer. So the bottom line is, clinical correlation is everything. You have to look at the whole clinical picture. And that picture really starts with the patient themselves. A true infection is almost always seen in patients who are already compromised. We're talking about folks with long ICU stays, patients with central lines or on ventilators, and, this is a big one, patients who have been on broad-spectrum antibiotics. The classic setup is a patient who was treated with carbapenems, which just wiped out all the competing bacteria and basically rolled out the red carpet for this intrinsically resistant bug. Now, when it does decide to cause trouble, the lungs are its favorite target, leading to things like hospital-acquired pneumonia. Bacteremia is also a really big deal, often tied to colonized catheters, and unfortunately, it comes with a pretty high mortality rate. And in patients who are immunocompromised, you can also see a whole range of skin and soft tissue infections. Okay, this brings us to the absolute core of what makes Stenotrophomonas Maltophilia such a problem. Its incredible built-in resistance to antibiotics. The concept you have to get your head around here is the intrinsic resistome. This isn't about the bacteria picking up a resistance plasmid. No, Stenotrophomonas Maltophilia is basically born this way. It comes preloaded with a whole toolkit of resistance genes right on its chromosome, making it a tough nut to crack right from the very start. And here's a look at that amazing toolkit. The big players are its 2 beta-lactamases. The L1 metallobeta-lactamase just chews through almost all beta-lactams, including every single carbapenem. Then you've got the L2 serine beta-lactamase adding to the chaos. On top of that, it has these powerful efflux pumps that just spit antibiotics right back out, and specific genes that protect it from other drugs like quinolones. It's a truly multi-layered defense system. So, faced with that incredible resistance profile, how in the world do we actually treat these infections? Let's take a look at the current strategies recommended in the guideline. When you look at the big picture, you kind of see two main philosophies. You've got the Dutch approach, which really leans into targeted, high-dose monotherapy, with cotrimoxazole being the star player. On the other hand, international guidelines from groups like the IDSA are now leaning more towards combination therapy for serious infections, hoping to improve outcomes. So here's that Dutch approach in a nutshell. It's very direct. For the most common infections, pneumonia, bacteremia, complicated UTIs, the go-to treatment is high-dose cotrimoxazole, usually 1,920 milligrams, given every 8 hours. The IDSA guidance is definitely a bit more complex, and that just reflects how tough these infections can be. For serious disease, they're suggesting combinations. Cefiderocol is now listed as a preferred agent to include. Minocycline is another really solid option, and they also point out this clever dual beta-lactam strategy, using ceftazidime avibactam plus astrionum together. The idea there is to specifically knock out both the L1 and the L2 enzymes. Now, in kids, the main player is still high-dose cotrimoxazole. Levofloxacin is an alternative. Of course, you have to remember the age restrictions on drugs like minocycline, so you generally avoid that in younger children. And cefiderocol is starting to look like a good option for salvage therapy, though we're still waiting on more pediatric data. Okay, back in the lab, this one's for us. Interpreting the susceptibility results for Stenotrophomonas Maltophilia is really tricky, and the EU-CAS breakpoints reflect that. The key thing to remember is how specific these are. The cotrimoxazole breakpoint, for example, assumes the patient is getting high-dose therapy. The levofloxacin breakpoint is only for uncomplicated UTIs, and for a lot of these drugs, that I category, susceptible increased exposure, is so important. It's telling us that to be effective, you need optimized high-dose therapy. You know, given how hard it is to treat this bug, stopping the infection from ever happening is obviously the best strategy. So let's pivot and talk about the all-important topic of infection prevention and control. And this chart just says it all, doesn't it? It screams one thing loud and clear. Stenotrophomonas maltophilia is an environmental pathogen. The vast majority of transmissions come from the hospital environment. We're talking sinks, faucets, respiratory equipment. This isn't primarily spreading from patient to patient. So our strategy to control it has to have multiple layers. Hand hygiene is, of course, absolutely fundamental. But the real wins come from controlling the environment, managing our water systems, and being incredibly strict about disinfecting equipment. And, just as importantly, we need smart antimicrobial stewardship to ease up on the carbapenem pressure that lets this organism thrive in the first place. And this brings us right to our final question, something to really think about. For decades, cotrimoxazole has been our workhorse, but now, with powerful new drugs like cefiderocol coming into play, are we about to see a fundamental shift in how we treat these infections? Will combination therapy become the new normal? And that's our look at Stenotrophomonas maltophilia. If you found this deep dive useful for your work, please go ahead and subscribe to the channel. We have a lot more of these coming. And we really want to hear from you. This should be a conversation, so please, leave your own experiences, your questions, or your hospital's protocols down in the comments below. We read every single one. Thanks so much for tuning in.